All right, suppose we have two right triangles that are similar to each other, okay? And the proportion of these two triangles is 7, okay? This particular right triangle has legs that measure at 3 and 4, and if you use the Pythagorean theorem, that gives us a hypotenuse that's equal to 5. Well, if the proportion is 7, then the hypotenuse of this larger one is going to be 7 times 5, which is 35. And this leg down here corresponds to this leg. This is a shorter leg, and this is the shorter leg. So if we do 3 times 7, that's 21. And then this leg is the longer leg, okay? And this leg is 4 with a proportion of 7, so 4 times 7, that's 28. So the length of this leg is 28, okay? Now, because these two triangles are similar, we know that their angles are congruent. They're corresponding angles. This is the smallest angle, so it corresponds to the smallest angle over here. This is a right angle, so it corresponds to the right angle over here. This angle is the medium angle, and it corresponds to this medium angle over here. And these angles are congruent. They're the same measure. So if this angle is angle theta, then this angle is also angle theta. And that's very important with similar triangles. If you have two triangles that are similar and you name one of the angles in one of them theta, you can name that corresponding angle in the other one theta because they are congruent angles. Okay, their measures are equal. So what I want to do here is I want to remember that this is the hypotenuse, and over here this is the hypotenuse, okay? But what would we call this leg relative to theta? Well, this leg is the leg that's far away from theta. So this leg right here is opposite theta, okay? Similarly, this leg right here, 28, is also across from theta. It's far away from theta, so this leg right here is opposite theta, okay? And that makes this leg, the 3, that makes it adjacent to theta, and this leg is also adjacent to theta. And that is a feature of similar triangles. If you have two right triangles that are similar, then the side that is called opposite to one angle is going to be, its corresponding side is also going to be opposite to that same angle in the other triangle, the similar triangle, okay? So here's what I want to show you is what if we were to create a fraction, and that fraction in that fraction what we do is we do the opposite of theta. We do the side that's opposite of theta and divide it by the hypotenuse, okay? So we're going to do opposite of theta divided by hypotenuse. Well, here opposite of theta is 4. And so that fraction would be 4 in the numerator, and the denominator is going to be the hypotenuse. And here the hypotenuse is 5. So that fraction would be 4 over 5. So if I said that I wanted a fraction that's relative to theta, and it's opposite of theta divided by hypotenuse, it would be 4 over 5. I could do the same thing over here. I could do the opposite of theta over hypotenuse. But over here, the numbers would be a little different. Opposite of theta is 28, divided by the hypotenuse, which is 35. But let me show you something. This fraction can be reduced because 28 can be divided by 7, and 35 can also be divided by 7. And if you were to reduce this fraction, you would wind up with 4 over 5, which is the same as this one over here, 4 over 5. And so here's what I want you to know, is that if we were to do a fraction of one of the legs divided by the hypotenuse, it would be the same fraction in a similar triangle. But they would have to be referring to the exact same angle, which in this case we're calling theta, okay? And so what that means is this. It means that this fraction of a leg divided by the hypotenuse is not a feature of the triangle. It's a feature of the angle. So this 4/5 ratio is not a characteristic of the triangle, it's actually a characteristic of the angle. This 4/5 ratio is a feature of the angle theta. So it doesn't matter what triangle you put the same angle theta in, you will always get the ratio 4/5 because we put it in a larger triangle over here and we still got the ratio 4:5. So what I want to do now is I want to talk about this ratio opposite over hypotenuse, and then there's another ratio that's very similar to it, which is the adjacent of theta over hypotenuse. These two fractions, opposite over hypotenuse and adjacent over hypotenuse, are two of the most important fractions in all of mathematics. All right, so these fractions that we're talking about, we call them the sine and the cosine of an angle. That every angle has a characteristic called the angle's sine and the angle's cosine. Okay, so you're going to see these words a good bit. Okay, let's define them. Okay, let's call this acute angle here. We're going to call it theta, like we've been calling a lot of the angles, theta. Okay, and so since this is theta, we can say that this is the hypotenuse. Hypotenuse, which we've already been saying, the hypotenuse is always the hypotenuse. But based on this angle theta, this side over here is across from theta, and that makes this the opposite side. And then this side right here is touching theta, the angle theta. It's a part of the angle, right? The angle is made up of these two lines, right? These two sides of the triangle, and one of the sides is this side, so this is the adjacent side, ADJ, the adjacent side. So this is adjacent to theta, and this side is opposite theta, okay? All right, so given an angle, an acute angle theta, the sine of an acute angle in a right triangle is the ratio or fraction of the opposite side over the hypotenuse. And here's how we write it. We say sine, but we take the E off. Okay? It's sine. This is not sin. This is a long I. It's I, sine. Sine of theta, this is a theta, sine of theta is equal to the length of the opposite side divided by the hypotenuse. Okay, so whatever side is opposite of sine goes in the numerator, and then the hypotenuse goes in the denominator. Okay, and so let's say that the length of this side right here is 3, like we had before, 3, and the hypotenuse is 5. Well, then the sine of theta, we would say the sine of theta in this case is equal to the opposite side, 3, divided by the hypotenuse, 5. So we would just say that sine of theta is 3/5. Okay? Do your best not to complicate this. That's really all there is to it. If you want to know the sine of an angle, just put the measure of the opposite side in the numerator and the measure of the hypotenuse in the denominator, and you're done. Now let's talk about the cosine of an acute angle. The cosine of an acute angle in a right triangle is the ratio or fraction of the adjacent side over the hypotenuse. And so we would write this as COS, that's cosine, just COS. That means cosine of theta is equal to the measure of the adjacent side, ADJ, divided by the hypotenuse, HYP. Okay, and so over here, if a hypotenuse is 5 and opposite side is 3, then by the Pythagorean theorem, the adjacent side would be 4. Okay, and so if this is theta, the adjacent side is 4 and the hypotenuse is 5, and therefore the cosine of theta is just simply the measure of the adjacent side, 4, over the hypotenuse, which is 5. So the cosine of theta is 4/5. And that's all there is to it. Let's do some examples. All right, so what we're going to do is I'm going to show you a triangle with 3 sides and the measures of all 3 sides. And we're going to identify the sine. We're going to pick one of the angles to be theta. We're going to identify the sine of theta and the cosine of theta. We're going to use the formulas. Sine of theta is opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. Okay, that's all we're going to do. So let's bring a triangle in. All right, so here's a triangle. We can see here that the hypotenuse is 13, and remember the hypotenuse is always the longest side. So we have a 5, we have a 12, and we have a 13. That automatically means the hypotenuse is 13. Okay, one of the legs is 5 and one of the legs is 12. Well, here's angle theta over here. So is 12 the opposite side or is that the adjacent side? Well, it's really close to theta. It's right here. Look, it's, theta is touching this side. So that makes 12 the adjacent side. We already know that 13 is the hypotenuse, right? And 5, if you draw an arrow straight out inside the triangle from theta all the way across the triangle, you would hit the opposite side. So this 5, that's the opposite side. Okay? All right, great. So sine is just simply opposite, that's 5, divided by hypotenuse, that's 13. So the sine of theta is 5 over 13. Cosine is the adjacent side, that's 12, divided by the hypotenuse, that's 13. So cosine is 12 over 13. That's it. Moving on to the next triangle. All right, now look what we have here. This is the same triangle. Look, it has a hypotenuse of 13, it has a leg of 5, and it has a leg of 12. This is the exact same triangle, but we've changed its orientation. We've reflected it, and we've also rotated it, okay? And look, here's theta right here. And what you'll notice is that theta is actually in the other angle. When we used this triangle a minute ago, that theta was in this angle here, and 12 was the opposite, or was the adjacent side. But now look, here's theta, and the adjacent side is now 5. Why? Because we moved theta. We went to a different angle. And so 5 is now the adjacent side, 12 is now the opposite side, and 13 is still the hypotenuse. Okay? But now when we go to do sine, last time sine was 5 over 13, but now sine is opposite over hypotenuse as usual, and opposite is 12. So we're going to do 12 over hypotenuse, 12 over 13. Now if you recall, if you look back a minute, before cosine was 12 over 13. When theta was in this other angle, cosine was 12 over 13. But now that we've moved theta to the other angle, sine is now 12 over 13. And there's meaningfulness to that phenomenon, okay? And then cosine of theta now, with theta here instead of over here, theta is going to be adjacent, that's 5 over hypotenuse 13. 5 over 13, okay? Let's do another triangle. All right, now we've got another right triangle. It has one leg is 15, one leg is 8, and the hypotenuse is 17, okay? So here's our hypotenuse, 17, okay? Here's theta over here, and so this 8 over here is far away from theta. It's across from theta. That means 8 is the opposite side, and that means that 15, which is right next to theta, 15 is the adjacent side, okay? So if we want to do the sine of theta, we want the opposite over hypotenuse. Well, opposite is 8 over hypotenuse is 17, so 8 over 17. That's it. Now cosine is adjacent over hypotenuse. Adjacent is 15, hypotenuse is 17. So the cosine of the angle is 15 over 17. There's nothing more to it than that. That is all. Let's do one more example. All right, so we've got another right triangle here. The hypotenuse is 53, HYP. Here's angle theta. We've got one leg that's 45 and one leg that's 28, okay? And the side, the leg of the triangle, the leg of the right triangle that's right next to theta, that's 45. That makes 45 the adjacent side. And all the way across the other side from theta is 28. That means that the opposite side, or the leg that's opposite theta, is 28, okay? And so if we want sine, we're going to do opposite divided by hypotenuse. Opposite is 28, hypotenuse is 53, so it's going to be 28 over 53. Cosine is adjacent divided by hypotenuse. That's 45 divided by 53. 45 divided by 53. And that's it. That is the sine and cosine of the angle.